Alright, so with this unit, this is applications linear systems, so we're actually going to use the equations, write equations, and then use them to solve, and we're going to have to make systems because we're going to have two separate variables. So this is kind of a quick overview, writing systems of linear equations, and then here are three ways we can do this: graphing, substitution, and elimination. In graphing, it says use graphing for solving systems that are easily graphed. So remember, the easily graphed ones are like the y equals mx plus b. If the point of intersection does not have integers for coordinates, find the exact solution by using one of the methods below. So if it doesn't fall directly on a grid point, you need to use another method because you need it to be as exact as you can. Substitution, use substitution for solving systems when one variable has a coefficient of 1 or negative 1. So remember, that's like y equals x plus 2, and then the other one could be 3x plus 4y equals whatever. And then elimination, you can use that for solving any system. You might need to change it around, translate it into a different form. So what we're going to do is, some of these word problems can be a little bit confusing. There are more examples in your book, so I would encourage you to also use your book to help you as well. But I'm going to kind of explain them the best I can, and then please do the best you can. So it says a metal worker has some ingots of metal alloy that are 25% copper alloy and 50% copper alloy. How many kilograms of each type of ingot should the metal worker combine to create 40 kilograms of 45% copper alloy? How many kilograms of each do you need? So basically what they're doing is they're taking two different types of metal. One of them has 25% copper and the other one is 50% copper, and they're going to combine these together to create this 40 kilograms of 45% copper. So they're going to put things together to create this happening. So what I'm going to say here is that I'm going to define my variables. I'm going to let x be the amount of the 25% copper alloy. I'm going to abbreviate there. And then I'm going to let y be the amount of 50% copper alloy. And so now what we need to do is just create two equations, because we have two separate variables, so we can't just write one equation to be able to solve this. Two things that I know is that I know the total mass, so this 40 kilograms right here. So if I add the amount of the 25% plus the amount of the 50%, the total is going to be 40 kilograms. So that's my first equation. My second equation is, it has to do with the percentages. So remember, to find a percent of a number, we would do 0.25. So it's 25% of this amount plus 50% of the y. And then here's the amount of that you want total, but only 45% of that is going to be your copper. So this is how you would write these two equations to help you solve this problem. And so what I would do next, if I were you, is I would rewrite this equation so like this multiplication is already done out for you. So we have x plus y equals 40, and then this would be 2.25x plus 0.5y, and then when you find 45% of 40, that equals 36. No, it doesn't. How about that equals 18? Sorry, I got ahead of myself. So that equals 18. And then, because these are both set up in standard form, the easiest way to cancel out would be, or the easiest way to solve them would be through elimination. So I'm actually going to take this equation down here and multiply it by 2. So that way I can cross out my y's. So again, I'm just going to copy this one equation over. X plus y equals 40. Then I'm going to multiply everything by 2. So 0.25 times 2 is 0.5x. 0.5 times 2 is going to be your 1y. And then 2 times 18 is 36. That's where I got the 36 from before. Now in order to eliminate, I am going to have to subtract here. So this is 1x minus 0.5 is 0.5x. These will cross out. And then 40 minus 36 is 4. Divide by the 0.5 to get x is equal to 8 kilograms. And then my y, if you just kind of go back up to here, right, where x plus y equals 40, so this would have to be 32 kilograms. So they would need 8 kilograms of the 25% alloy and 32 kilograms of the 45% alloy. Okay. So this next one is talking about break-even points. So it says, suppose an antique car club publishes a newsletter. Expenses are 35 cents for printing and mailing each copy, plus $770 total for research and writing. The price of the newsletter is 55 cents per copy. How many copies of the newsletter must the club sell to break even? So we need to define our variables again. There's two things that we have. X could be the number of copies, like how many copies we have to sell. And then Y is going to be the amount of expenses or income. Because of this is going to be a break-even point, it's the amount of expenses or income. So let's look at expenses first. So the expenses, if you look back up at the top, is 35 cents for printing and mailing each copy plus $770 total. And so with that, the expenses, which is your Y, is equal to 0.35x plus 770. And then we also have income. And the income, that's how much you're going to make per copy, is the 55 cents, because that's what you're selling it for. So the income is just 0.55x, because that's how much you're making. Now, if I look here, I have y equals and y equals. So y is equal to this, but y is also equal to this, which means that the 0.35x plus 770 is also equal to the 0.55x. That's where it's going to break even, is when they're equal to one another. When the expenses, here's my expenses, is equal to my income. And so now what we're going to do is just go through and solve this. So get our x's to one side. 770 is equal to 0.20x. Divide by 0.20. So x is equal to 3,850 copies. And then just go back up at the top. Maybe we don't even need to solve for that next one. Because if you look here, it's saying how many copies of the newsletter must the club sell to break even. And so I don't even have to go any further than this. In order to break even, they would have to sell 3,850 copies. Now this next one, one thing that you need to understand a little bit of is airspeed and wind speed. It's talking about planes, and it says a plane takes about 6 hours to fly 2,400 miles from New York City to Seattle, Washington. At the same time, your friend flies from Seattle to New York City. His plane, travels with the same average airspeed, but his flight takes 5 hours. Find the average airspeed of the planes and find the average wind speed. So I'm going to use A and W for this one. So A is going to actually represent the airspeed, and W is going to be representing the wind speed. What I can What I can tell by this is that, let me get my highlighter. It takes 6 hours to fly 2,400 miles, but then in the other direction it only takes 5 hours. And so it's telling me that his friend actually has some tailwind that's helping him go a little bit faster. And then the 6 hours, since it takes a little bit longer, they're probably flying into the headwind, so they're flying into the wind, which is called headwind. So we need to write two equations here. Basically, you have my plane, and like I said before, that one is going to have headwinds because it's taking me 6 hours, and then my friend is going to have tailwind because it's going to help push him along because his distance, his time is a little bit faster. And so this kind of goes back to, remember, rate times time equals distance. And then with air wind and headwind, so with headwind, you have to take, the airspeed minus the wind speed, because with that, the wind is going to help you out. But with a tailwind, you have to take airspeed plus the wind speed, because it's going to help you, with a headwind, that's going to slow you down, which is why you need to subtract, and then over here, you need to speed up. Sorry, I apologize, I explained that wrong. So that's the rate times the time equals the distance. The rate times the time equals the distance. Okay? You're always going to have this right here in these equations. You're always going to have either A minus W or A plus W. With the tailwind, it's going to be A plus W. With the headwind, it's going to be A minus W. And so with this one right here, A minus W, the amount of time was 5 hours, and the distance was your 2,400. And then over here, you're going to have your A plus W. This time was 6 hours. Nope, I just wrote that wrong. I wrote this opposite of what let me get my eraser. I apologize, you guys. I'm probably making this more confusing than I need to. So let's just retract for a second. With the let's get the highlighter. With headwind and tailwind, okay, headwind, it was going to take me 6 hours because I'm going against the wind. Tailwind, it was going to take me 5 hours because I'm going with the wind. The wind is going to help me travel along. So now if I haven't confused you enough, let's see if we can go through and solve this problem. So what we need to do is we actually need to go through and simplify this equation. In order to get the A minus W by itself, what I can do here is actually divide by 6 to cross that out. Then what I have is A minus W is equal to 400. And then I can do the same thing over here. I can divide by 5 on both sides to get A plus W is equal to 480. Now again, if you notice, I have A minus W and A plus W. I would use elimination here. Because if you notice, if I add these together, my W's will end up being able to eliminate. And so A plus A is 2A. My W's are going to cross out. This is 880 if I divide by 2. What this tells me is my airspeed is going to be 440. I don't know if it actually tells us up here. Miles per hour. Okay. And then remember, if I just go up to either one of these, I could go back to this one right here and just substitute in this airspeed here, and then that's going to allow me to find the wind speed. So it would end up being 440 minus W equals 400, and if I go through and solve that, W is going to end up equaling 40 miles per hour. So the airspeed is 440, wind speed is 40. And that is it for today. Like I said, you guys, there's more examples in your book in Section 4 of Chapter 7. I would really encourage you to go through and take a look at those other examples. They kind of break it down step by step. And I did get a little bit confusing as I was going through, especially with the airspeed and the wind speed one as we went through. So please do the best you can, and I will touch base when I get back. Talk to you guys later. Bye.